Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the simple problem majority element. Its index is 169 and it is the easy problem of the LeetCode daily challenge day 21. Okay, so let's begin. Given an array nums of size n and we have to return the majority element. So what is the majority element over here is the element that appears more than n by 2 times. Like n is the size of the array and n by 2, here it is the ceiling value, sorry, not ceiling value, it is the floor value of the result, n by 2. So you may assume the majority element always exists in the array. Okay, so how we are going to do that? There are a lot of ways to do that, like depends upon how you implement. Like it has a O of n square time complexity. Also it can have a it can also have O of n log n time complexity with O of n space. Like there are a lot of ways. I will try to cover all those ways in this video. Okay, so n is the nums dot length and max value of n is 5 into 10 raised to the power 4. Okay, so let's focus how we are going to do that. So first of all, I will try to implement O of n square time solution. So let me write down time complexity O of n square, and space complexity would be O of 1. Right, so majority element means the element which has more the frequency more than n by 2 times. So let's write n as nums dot size as first of all. So what I'm going to do is I'm going to pick out every element and claim that this can be the majority element by finding the frequency in the array. Right, so how I'm going to do is like let's say I will iterate in this nums. So claim that num is the majority element. Okay, so we will find the frequency of this num. So let's say int frequency is 0, and again we have to iterate in this array. So auto element num. So if this element is exactly equal to this num, okay, then you can see my frequency will be incremented by 1. And when we are able to do that, then we can check if frequency is greater than n by 2, then we can say we got the majority element. And this is the only majority element, because when some element has frequency more than n by 2, then anyhow the other element will always have a frequency less than this value n by 2. Okay, so there exists only one majority element. So what I'm going to do is I will assign majority element exactly equal to num, and here we are done, so we will use a break statement. Okay, so we will return majority element. Okay, so worst case time complexity would not go to O of n square, like because more than half of the elements will be filled by that majority element. But still, yeah, in general we can say that time complexity be O of n square, and we will assign majority element. Right, I think we have got the correct way to do that. Okay, so let's submit this one and check it out. Yeah, we can have a good solution or what. Yeah, you can see we got a TLE verdict, because the max n is like 5 into 10 raised to the power 4. So in the worst case you will get 5 into 10 raised to the power 4 square, and yeah, it would get a TLE verdict because number of iterations will be a lot. Okay, so let's try to optimize this one. So we will be talking about log n type solution. So the only change that we are going to do is like first of all we will store the frequencies of the elements, right? So we will use a map frequency table. Okay, so we will first store the frequencies of the elements, all the elements, distinct elements. So frequency table will increment the value that we got by 1, and we will iterate and check it out whether we are having the some element having frequency more than n by 2. So we are going to first of all write majority element, and we will iterate in the map. So I will itmp. So if it dot second is greater than the value n by 2, then we got the majority element. As it dot first, it dot second is actually the frequency, and if we got that, we are done. We'll use a break statement to stop it over here, and we'll return majority. I think MAJ majority element. Yeah. So you can see if I'm using a data structure called map, then yeah, it would always have insertion and deletion and logarithmic time complexity. So that's why the total complexity of this solution is n log n. I don't know why it's getting, yeah, I still haven't declared the n, so that's a very bad thing for me. Yeah, you can see now I think it will give us runtime 16 ms and faster than this solution, because n log n is still like 5 into 10 raised to the power 4 log of this value, so it will be like not much more than 10 raised to the power 6 around, I think. Yeah, maybe. So okay, so we would be talking about O of okay, so yeah, the previous solution was like taking O of n space, right? So yeah, that should be a point that you should take care for that, because map is storing the elements, and we are taking some, it is taking some space. Okay, so now we'll be showing how we can do this in O of n time and O of 1 space. Okay, so yeah, so we will keep track of okay, so first let me explain how the things will work. So suppose we have the elements 3 3 and 2, right? So whenever like this is the suppose we have the element in this array 3 3 2. So when we got 3, we will increment the frequency of the element. Right now the element is 3 and its frequency is 1. Okay, so when we got again 3, then we will increment the frequency of the element 3 by 1 again. So the element is 3 and frequency is 2. But when we got 2, you can see it is actually claiming that yes, it can have also in future that we have got some more 2's. In that case, you will assign the majority element as 2 also. So when we got another element when we got another element which is not matching with our current element that we are keeping track of, then we will decrement the frequency. Okay, so if you're not getting it, so let me take this example. Okay, so now it is, you can see the majority element is 2. So my current element is 3 and its frequency is 1, because we are only dealing with this element 3. Okay, so again, my if another 3 comes up, we will write so my element would be considering would be 3 and 3, and element is 3 and frequency is 2. Okay, now again you can see I have got the element 3 3 2. Okay, now again you can see when a 2 comes, it is not matching with this element that we are keeping track of. So in that case, what I am going to do is element becomes 2 and frequency becomes 1. Like sorry, element will still remain 3. We will change the element only when the frequency becomes 0. So because this will decrement the priority. When we got a different element, we have to decrement the frequency that we are keeping track of, because it is actually demanding that it can be the majority element in future. So we will decrement the frequency of that element we are keeping track of. Okay, and again you can see when we got another element 3 3 2 and 2, in that case you can see element becomes again 3, because still the frequency is now you can see the frequency becomes 0 right now, but we are not going to do that. In the next iteration, if that element exists, then we are going to do that. Okay, so frequency becomes 0. Okay, now you can see we have got another 2 right now. So right now we are getting the 2 and the previous frequency is 0. So we will do element as 2 and frequency as 1, and here our iteration stops. Right, you can see now majority element is actually 2. Okay, so this will be our answer. And what about when we got 3? Right now here it is 3. In that case you can see my previous frequency is 0 and this element is matching with the previous element. Right now it is 3 and this it is matching with this one. So we are not going to change our element variable. The element remains 3 and frequency changes to 1. So this is actually the entire concept. So we will decrement. So what I'm going to do is majority element will remain as 1, sorry, nums of 0, and its count will be exactly 1. Note that this is not the frequency. Count doesn't denote the frequency. Counts denote the difference actually. Okay, so if count is already 0, okay, so like you can see in that case when we are at this step, the previous count was 0. Okay, so we will first check if nums of I is exactly matching with majority element, then yeah, you will increment the frequency by 1. But what about it is not matching? So the only thing that you are going to do is you are going to change the majority element and this nums of I. So I'm going to do swap nums of I and majority element, element, right? And this spelling is also wrong. Okay, so let me copy it down because we are going to use that a lot of places, maybe. Yeah, and yeah, and you're now also going to increment the count in either of the case. And what about when nums of I exactly matching with majority element? In that case you will increment the count, otherwise you will decrement the count. And when the iteration ends, you will be having the majority element right over here. So let's run the code and check it out. Yeah, it's working fine. So let's submit that. Yeah, it's good. Okay, you can also, like, yeah, this was the case. In the previous case you can also do one thing, that complexity can be, you can see time complexity was actually n log n, and space complexity was actually O of n. You can make that O of n by using the unordered map. It has an average time as O of n. In that case you would also have a good runtime. Yeah, okay. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.